Yes, ma'am.
Okay. So for the last session, what we were discussing was about how to do estimation, and we did discuss about the relevance of the same. And I did mention that we are here at SNR using software for estimation so that we can speed up the process and reduce the error. So today you will be having a slide demonstration on how do we how we do the estimation in our pattern, and you will be learning the same in the coming sessions. Initially, I thought of starting with the drafting portion, but I think it's better you get a glimpse of what actually you are doing. Then we'll continue with what the actual procedure. Okay, so just let me know when my screen is visible to you. Is my screen visible?
Yes, ma'am.
Okay, now you have a image in front of you. Now from this image, you can see it's a plan of a building, and it has a living room, dining, master bedroom, and toilets. Okay, so this is a simple plan, and we'll be looking into the estimation of this particular plan. Now, the first step, if you are getting an image file, the first step will be to convert it to an AutoCAD file. There is no direct method to convert an image to an AutoCAD file. Only way is to draft the same. Meanwhile, you can convert a PDF file to direct AutoCAD if the file was initially created in AutoCAD. So if someone has exported a PDF file from an AutoCAD file, you have a chance for uh, bringing it back to AutoCAD in proper layers just by importing it. The method is that you have to use this insert command in AutoCAD, use the PDF import option, select the same, and select the drawing, and you can bring it back to AutoCAD as a drawing itself. But this is not possible for a PDF which has been saved from a image. So if you're converting an image to PDF, the same won't be converted to lines in AutoCAD, but a proper file which was drafted in AutoCAD and converted to PDF can be brought back to AutoCAD and converted to a proper drawing. Now I'll just see if I can give an example. Okay, let me see if I can bring a PDF drawing. Okay, now I have selected a PDF file. Click open. Now the file is here. Now you have some inputs over here. The scale of the drawing, rotation, let it be a vector, solid fill, and true line type. Okay, then click OK. Come to your drawing. You can take a free drawing and place it. You can see that it has been converted. I'll just remove this one. I have lost some layers in the process. So this file has not been properly converted. Uh, and that's why it was not properly brought in. If it's a proper file, you might be able to get the lines properly. Let me check again. If I have any other files available. This one is not a convertible one. Okay, I'll just stop this over here. You can try out. I'll give a PDF for trying out the same in your WhatsApp chat. Okay. Now, for the time being, just understand that you have the insert option from wherein you can bring a drawing in image as well as PDF into AutoCAD platform. So you can use it as a reference for drafting this diagram. Now, you can do is that you can import this drawing in image to this one. Open, click anywhere, you scale up a bit, and you have the drawing in AutoCAD. Now, if the drawing is not in proper units, so here it's used in feet, And I'll be sharing some files in terms which is written in feet. So you can follow this procedure also. You can see that the dimensions are in feet. You can either draft it in feet itself and scale it accordingly, or you can convert the same and then draft. Converting and drafting is a tedious process because you have decimal values and it will be a bit difficult to round off and take the actual value properly. So it's better you can draw the same values in feet and later scale the entire drawing in as such to get the proper size in centimeter. Now, as you can see, this particular drawing was prepared in the unit centimeter. And the reason for the same is being that the Estimax template or the Estimax template input has to be in centimeter for the particular template I'm using. If you're using another template, you can go for a different unit. Now, the first step for estimation is that you have to draft the drawing in AutoCAD. If in case an AutoCAD drawing is already given, you may do a bit of corrections and directly proceed with the estimation. Now, as in this case, you have the AutoCAD drawing in your hand, and you can see that there are different colors and layers used in this drawing. Now, the different layers, and you have different color codes to indicate each layer so that you can easily distinguish by just looking into the same. Now, you can see that windows are marked as well as the walls are being drawn. Just off a few layer, get a better view with that. Okay. Now, these green ones are the walls, and these are the joineries. So joinery means windows, doors, and other openings that you provide in a building. Now, I have kitchen windows, window in the master bedroom, toilet ventilators, and windows for the living area. I have doors D1, D1, TD. TD represents a toilet door. Okay, only two types of doors are over here. And the next plan, this is called a headroom plan. This is given so that you can land and have a covered area over here. If this is open to sky or open area, you need not provide a wall. But when you are doing estimation, better do it as a closed area so that the staircase is protected from rainwater as well as extreme temperatures. Okay. Now I have two plans over here. One is the ground floor plan, another one is the headroom plan with the headroom area over here. And I have three structure drawings. One for the foundation, plinth beam. Next for the ground floor, the roof beams of ground floor. That is the first floor beams. And then we have the headroom beams. So this is not just beams, beam and column layout. The same thing you prepared for your structure training, the same is being used over here. And I guess I have given sufficient drawings for practicing beam column layout earlier. You may use the same files for estimation also. And in the architecture drawing, we have three main factors. That is a wall, joinery, and columns. These are three important things. Even if you ignore the text for each rooms, or even if you ignore the staircase itself, it's okay. But when you are going for scanning or estimation part, you will have to keep the walls as well as the joinery in this drawing. Walls, joinery, and the column. These are three main elements to be drafted while preparing the drawing. Now coming to estimation part. Once you have completed the drafting, you'll go for estimation in Estimax. This is the main interface you see once you open the application. And you can see that initially you have options for new project, opening a project, and closing the window. And rest all icons are being locked. This is because you haven't started working with the file. And you have the help option active. Now coming to the file part, we will start with a new project. Now you can give the project name, and here you can say that by default the unit is given as centimeter. That is the main reason why I did draft the drawing in centimeter. If I was using a different drawing unit, I should have adopted the same in the drawing as well as in this particular window. Now, showing a rate analysis is for the next window, wherein you can see the detailed rate analysis or choose for the concise one. Then the project details, you can enter the project name, client name, region name, and you can fill in some other details like the electrification plumbing cost. Why is it in percentage? Because here, currently using estimation, we are only calculating the civil related works, not the electrical or plumbing works are being calculated in actual terms of numbers, or a proper estimate is not taken. Instead, we are taking it as a percentage of the total estimated amount. And that will be 5% of the total estimated amount currently. You can fill in the client name and the region name. Then save. Now we are going to start with the estimation part. And for this, I think we have covered Revit training for you. So I think you are familiar with the word template. You'll be using a template for working with Revit. Similarly, when you work with Estimax, you'll have a template. A template is a template serves as a guideline wherein you have the proper rate analysis already prepared. So only thing you will have to do is to take the quantities from the drawing. You don't have to prepare the rate analysis. Rate analysis will be already prepared and stored in different templates based on the requirement. So you have templates for CPWD in meters. The output will be in terms of meters. You can have it in mm. You can have it in centimeter for PWD. Now we'll have templates for other it's also. I'll use this one. You can choose a template as per your requirement to produce a given report. Now this is the main page where you work with the software. Here you can see a list of items, the unit, quantity, and rate. Earlier, we had an option for selecting rate analysis, yes or no. That was mainly to add rate analysis in this particular page. That is not necessary because you can go to the detail of rate analysis in here. And in the reports, you have an option for summary report wherein you will get the rate analysis also included. So it's better you keep this page as simple as it for easy review. Now coming to the scanning part, you have 5 different steps. The first step is to set the parameters. You'll have to set a set of parameters initially. For same projects, you may not have to redo it every time. For initially, you will have to set these parameters and you can work with the same. Then we have scanning part. You'll do the arc scan as well as the structure scan. Then you have the footing and staircase calculation as the third part. Then we have the CAD utilities. That means these entities like the kitchen slab or the reduction for this particular area or even the terrace waterproofing. These are entities we cannot define as such. This will vary with each project. So in order to cover up such entity, such calculations or quantities which vary with each project, we are using certain polylines. These polylines are called CAD utilities. So the kitchen finish is denoted by a polyline having a layer named kitchen finish, and this is scanned into the Estimax to get the area to be covered with granite. Similarly, you have a CAD utility for anti-skid flooring. You have a CAD utility for toilet dado. So, and you have a CAD utility for wash area. Since the drawing is not having a wash area, I have not given the same. You do have a option for the same. The some other CAD utilities also, which I have already offed over here, like the outer plaster line and outer plaster reduction, inner plaster line. Now, why should we use an outer plaster line instead of taking from the center line? Now, all the calculations are done based on the center line of these walls. Why should we take an extra effort to draft this? It's simply because At some places, we don't require to give the inner plastic. We might go for a direct wall texturing or some other material to cover up the wall instead of going for a plastering. Or you might go for a grade 1 brickwork wherein you don't require plastering at all. So such situations, you can avoid plastering by using these CAD utilities. Okay. Now, there are a few CAD utilities which you have to learn while using the software and using different templates also. That you don't have to worry, you'll get a table for the same. You can keep referring to the same while you work until you master the same. Now we'll go for the estimation part. I'll do a quick demo so that we don't waste much time. Now for setting the parameters. And the last point while doing estimation is after doing CAD utilities, the next one is to prepare the report. And that is a 1-minute procedure. Less than 1-minute procedure actually. Now for setting the parameters, initially we set the project details. I won't be updating it. Then we have a few project defaults like the slab thickness, sunshade width. I'll be changing it to 45. Pedestal height, I can go for 110 based on my current requirement. Then beam depth. This beam depth refers to the depth of plinth beam, not the beam depth of entire floors, but for the plinth beam itself. And PCC thickness, this refers to the PCC provided under all the foundations. It can be for plinth beam, it can be for the flooring area. All this PCC is included in this particular thickness. Then we have the thread rise for the staircase. I'll go for 30 thread and 15 rise. You may also measure the same from the drawing. It will vary with drawing, so it's better you take the values from the drawing and enter the same in the window. I'm just assuming so that we can complete this as soon as possible. Then we have a staircase width. You can fill in the same, and number of steps is 20. Parapet height as per the artist drawing, fill in the same. And even parapet thickness, I can go for a 10 centimeter thick wall rather than a 15 centimeter. Lintel depth will be based on the lintel thickness of mentioned in your structure drawing. Now, if it's a load bearing structure, it is supposed to have varying lintel depth, and the lintel depth will be based on the width of the opening. So if a window is more than 2 meter wide, then the lintel depth will be more than 15 based on the requirement for the same and the height of the room. Okay, it is a calculation done by a structural engineer, and the same will be given while giving the structural drawings. You can refer the same for the value. And for the time being, you may assume it to be 15, which is usually the value taken for normal windows of smaller width. Then you can go for the lintel thickness. Lintel thickness is usually equivalent to the width of the wall. I'll be taking it as 23, including plastering. Or you can even exclude plastering and take 20. Okay. The number of residents is usually referred to the number of people who will reside in the building after construction. And this is directly linked with the capacity of water tank as well as the soak pit. So this is for the calculation of water tank underground and overhead water tank quantity, if it is going to be constructed using RCC. If it's plastic, you may not use this value. Okay, if it's for 4 people, the capacity, based on the capacity, the size will be 215, 165, and 150. This will be 100 height. Now this is the width including the thickness of wall. I'll give references for the same if you're planning to do the estimation. Now we have the story. When we say about story, the meaning is that it is a play similar to the division we use in Revit. So just have a building section. Now say go for building section and go for a simple one. As you see in this building, You can see it's marked as first floor, second floor, fourth floor, flat roof and all. Each portion between these two reference line is taken as one story. So all these quantity, all the quantity that is likely to come in this particular zone will be taken in that particular story. So if it's under ground floor, it is taken as foundation. Between ground floor and first floor, it is taken as ground story. First and second, it is taken as first floor story. Okay, that is the concept behind the same. So story will be the area between that two reference lines. And these reference lines are usually given in your section drawing of the building. Now for the foundation part, I'm taking the story height as 40, which is equivalent to the plinth beam height. And this might vary if you have a brickwork above the plinth beam or you have a basement, then the height of that portion or the story will be changing based on the section drawing of the building. And here brick height is taken as approximately 0 because you can't keep this value 0. It will turn as an error. I'll just show. If I try saying as 0, it will treat as an error that brick height is not given. You can give a value equivalent to 0 so that it is then we will go for the ground floor. Here you can see that story height can be taken as 310 and I have to add the brick height. So what is the brick height of a building? Brick height of a building simply means the height after removing the RCC elements in that particular portion. You can see, wait, okay. Now in this particular plan, you can see that there is a beam over here. There is a door over here. And above this door, there is likely to be a lintel also. So we have to reduce the height of the beam, the slab, and the lintel so as to get the total brick height in this particular cross section. And when we come over here, we don't have a lintel over here. We just have a beam slab, which is to be deducted from the total height of this building. So if we are taking 2.85 as the height of this particular floor or the story height, then the brick height will be 2.85 minus depth of beam, because depth of beam, the top level of beam and the slab is same. So the slab depth is already included in the beam depth. You don't have to subtract it separately. So we can just deduct the beam depth to get the remaining brick height. So this is varying. Wherever you don't have a lintel, you don't have to reduce the depth of lintel. So for doing it a simple way, you just have to reduce the beam depth initially and we'll remove the lintel depth later while doing the calculation for joinery. So in our case, the height is 310. I'm entering the values in centimeter because my template is in centimeter. Minus, and the depth of the beam is taken as 40. Okay, I have 270 as the brick height wherever there is no opening. And the same will be entered over here. Save the same. Yes. And if you want to create a new story, you can do it from here and save or delete the same as per your requirement. Then we'll go for the headroom part. Headroom, usually the minimum height, the minimum clear height should be 210 centimeters. So I'm taking the same. That is the height of the door given over there. I am not going to give a lintel over there. So lintel height is 0. Door will be directly resting on the under the beam. So there is no brickwork also. Directly the story height will be 210 plus 40, that is 250. Save the same. Yes, and close. The story has been fixed. Now we'll move to the joinery details. You don't have to create this table by typing in. Instead, you can delete the same and scan it from the AutoCAD file. The table is already prepared in AutoCAD. And for this case, I have already prepared the joinery table over here. The joinery table should have the length, width, and CAD notations. Now here you can see door, the length, width, and CAD notation. You might be wondering why I'm having a decimal over here, because all these door and window sizes are given in feet. So the converted values are in decimals. You may round it out. I prefer to keep it in decimal up to 2 digits. Now, after scanning the same, just change the joinery type over here. You have a drop down. You can select it from the same. Or to make it quick, you can just select the window, type D, and select the next window, type D. The rest is windows, and I'll have to change for the ventilator. It's type V. I'll have to change the lintel depth. Why is it given to change the lintel depth on our own? This is because the lintel depth might be varying in certain cases. So instead of fixing a certain value, you can change it accordingly. All these values are changeable. If required, you can change it. And make sure that any changes to the joinery table have to be done in the initial stage itself. Correcting it in a later stage will not change your final report. So it's better you fix the joinery at the starting, and then later on, don't bother to change it again. If you are changing it, you better go to the scan report and change it over there also. I'm changing it here. I'm changing the lintel depth to be 15. Okay. And save the same. Now, after doing this, I don't have to do anything with joinery data, even the brick height above joinery, and all other calculations related to joinery will be done automatically. You have the rate types. Rate types means the category of rates. So material rates, labor rates, miscellaneous rates, it's a category. Then we have the rate analysis type. So this is a category for works. So all earth related works, that is you are handling earth, that is excavation, filling, all these are related to earthwork. You have RCC for column, beam, and etc. is combined in concrete and allied works. Even PCC is also coming under concrete and allied works. You have categories for work, which is called analysis type. Then we have the rate analysis over here. And you can see there is another option, conveyance. That means when you're transporting a material, as I have mentioned in my earlier session, when you're transporting a material from faraway place to your site, you will have to add on the transporting cost to the budget. And for the same, you will have to add the minimum rate, distance, total distance covered, and the total rate will be calculated automatically. And you'll get the total rate added based on the quantity to the rate analysis of each material. Now coming to rate analysis part, you can see there is rate analysis for all items done here. I am not saying that all work has been added in this template, but the basic works which we often come across have been added to this particular template so that we can save the time in preparing the rate analysis. And in case if there is a variation coming up, you can duplicate a copy and work on the same so that you can cut down time in adding a rate analysis. And usually we have only come across some variations from the actual ones available in the template. You may add new ones from this option. Okay, when we look into a rate analysis part, you can see there is a description, a detailed description regarding the same, which has been taken from the Delhi analysis of rates. You can see the conversion factors given here. Since this drawing is converting the centimeter values to m cube, the corresponding conversion factors has been given. Then we have the some miscellaneous data, which is for internal works. You can see the sunrise given, unit here, water and electricity percentage, machinery charges. If required, you can add it over here, or you can even add in this particular region along with the quantities. Then overhead and overhead charges and contractor profit can also be fixed over here. You can keep it varying. You need not give the same contractor profit for all rate analysis. You can keep it varying also. Now that is about the rate analysis part. You can, if you have done the BVS for the same, you can enter the BVS values. 6% means 6 diameter bar. So you can add the quantity of bar for the same. for sunshade, lintel, and all these from the BBS data and save it so that the steel quantity is also being displayed in the report. Otherwise, that will be omitted. Only the RCC quantity, that is the concrete quantity, will only be taken. And you'll have to go for the manual calculation for steel quantity. Then we have the work groups. All these data, right from analysis to work groups, these are uh, data which remains same for similar projects. You might have to change it only when you're dealing with a different project. Like if you're dealing with a residential project that is having a basement, then it will be a different case because I didn't have a basement in this particular story. So, and I'm having some other quantities like which is not already added in this particular list, then I can work on the same. Now we have different work groups, just like the work groups for rate, and we have subgroups for each work. Like sunshade is a subgroup for slab in this particular template. Subgroups will vary with each different template. So this is not a permanent thing. This is done for each template. You can change it. Then we have the story item details. This is a page where you control what is put in your output report. If you're morphing one item over here, that particular item will be removed from the output report. But the calculation for the same will be available in this particular file till you delete this file. Okay. Then here I'll be going for the scan. Now, once this is entire set is for fixing parameters. Once the parameters have been fixed, you can go for the scanning part. And before you go for the scanning part, you will have to set the story in which you are working. If you're not going for a foundation story scan initially, change it to the required one. Now I'll be going for the foundation scan and then for each other stories. When we come to the foundation part, here I'm assuming that my foundation consists of a plinth beam with and a combination of isolated footing. So I have a plinth beam and pedestal and isolated footing. So three elements are coming up in my foundation part. So I'll be going for scanning the plinth beam. There is no brickwork assumed in this particular section. So I will be skipping the slab detail as well as scanner part because the flooring which we give at plinth level is purely PCC and flooring material over the same. So there is no slab over there. I can skip that. And architecture scan, since I am not assuming any brickwork above the plinth beam, I can even skip this part. Then I will be going directly to the scan architectural part. Here I'll have to fix the properties first. The property is nothing other than the width of the expected width and the layer name. Now layer name, here you have layer names of beams and columns listed over here. And for the column, you have only one option. A single layer name is to be provided. The column size, irrespective of whatever is the column size, it will be scanned and the value will be calculated. For the beams, you'll have varying depth, which cannot be detected from the drawing directly because depth factors are not represented in the AutoCAD drawing. You will have to give the depth differently. And hence, we have different layers for different beam names. And you have to fix the depth and width of the beam. I'll go for 23 and depth will be 40. Maximum width will be 25. Why do we give a maximum width? This is because for the system, when it scans, and so 1-2 layers and show the same. For the system which scans our drawing, these two lines are parallel to each other. I'll just show this one. Okay, here we have a wall line. We have a wall line over here, parallel lines over here. We have parallel lines over here. If you're not setting a maximum width, what happens is that there will be a center line formed in between these lines because these two lines are also parallel to each other. The software is looking for parallel lines to create the center line. In order to avoid taking these two as parallel lines, we are going to fix the maximum width of wall. And I am taking it as 25 just to keep a upper limit. Now, once you have fixed the properties, close the same, go for scan. The drawing is automatically opened. This is because when we scan the joinery table itself, there is a link established between the AutoCAD file as well as the Estimax file. Come to the drawing, zoom out a bit and select the entire. No, I'm going to scan the plinth beam. So scan the plinth beam part. Enter. You can see center lines forming in between these lines, which is going to be used for calculating the quantity of materials. Now, by using center lines, what is actually happening? The center line length into width into height gives the volume of brickwork to be done. That is the main reason why we are taking center line of the wall. Similar calculation is done for finding the quantity of beam. Center line length into width into depth gives the volume of beam to be casted. Similarly, for columns, area of this polygon into height will be the volume of one column. And we can just multiply by the number of similar polygons to get the total volume of columns. That is a pattern in which the software calculates the value. And here you can see that the beam line is crossing the column. That means an extra quantity is being taken into account, so that we have to trim off this excess portion. If we go for trimming manually, it might be time consuming. So better you can do it from the software itself. You can provide 4 different corrections in the correct order of finding overlap center lines. Next, go for trim beams. Then for rejoining of beams. And finally, you have correct junctions option. While giving these 4 corrections, automatically the software will check for intersections and remove the center line from wherever there is column and wherever there is a beam to beam intersection, where there is a junction, so that the quantity is not taken twice. So double calculation is avoided and you can prevent errors from occurring also. And here you have 2 tabs, a scan tab as well as a details tab. Now details tab is a shorter form of the scan tab. Here you can see each center line wise data. I'll just mark the center lines in the drawing. You can see each center line is given an identity number and each column is also given a number. We come back to Estimax and select a particular number and press Alt. You can see that particular line is highlighted in the AutoCAD file. This shows that Estimax is linked to AutoCAD, and due to that link, you can easily identify the center lines given. If it's for 4, Alt and 4, you can see that particular line. And for rectangular columns, I can even highlight the same. Okay. Once the link between these 2 files are disconnected, the entire scan tab will be empty and there will be no data. That is the reason why you will have to keep the link between these 2 softwares intact as long as you want this estimation to be saved. Now save this file. Save. You just have to take note of the number of columns so that you can calculate the footing number. Close. Now next you have calculations for this. Refresh the page by clicking F5 or file refresh option. This is done so that you can get the quantities over here. You can see some empty spaces which is for the compound wall, outer plinth plastering and all. We have some more quantities to be scanned in to get all these filled up. Okay, now I'll go for the footing calculation. I have plinth beams, pedestals. As you can see, the pedestal quantity has already been accounted and the beam quantity has also been taken. Now the remaining part is for the footing. Go for the footing calculation. You have 2 options, sloped footing as well as stepped one. Slope footing looks something like this. You can fill in the data from the structure design, and I'll go for the step footing for this particular one. Now, name of the footing, number of steps, number of footing as per the column number. So I'll just go back and check the column number. I have 12 columns. So come back, step footing, name of footing. As per your structured drawing, you have naming for footing. You can use the same so that report looks similar. You can give you the number of steps. Steps means the number of steps in each footing. And the number of footing. C value is as per this image. You have to calculate it from the structure drawing. And for my particular drawing, it is 110. Then give this these values as per the same values given in your structure drawing. 180, 150, 30, 200, 170, 50. Now these values match with mine. I'm assuming that all my footings are of same size. Save. You'll get a dialog box over here. You can either close or you can even take the data from here. Export. You can export the calculation to property builder. Export to Excel options available so that you can review data stage also. Then close. Come. I won't be calculating the stair volume in this particular story level. In the ground floor level. So I'll be skipping this part and going to the tool side. So initially in the master side, we fixed the parameters. Entry side, we did the scanning, and tool side, we have to take a bit more quantities. Now after footing, I still have some unknown quantities like site clearance, plinth filling, okay, and the plinth pedestal portion. No, not the plinth pedestal. The outer plinth plastering. All these are related to the plinth area. Plinth area is not a constant for any building. It will vary with every building. So you have to give a polyline and scan the same to get the quantity for it. And I have already given a polyline to represent the same. Just select the polyline name from this list. I have named it as plinth. Then go for scan. Come to my AutoCAD file and scan the drawing. The polyline in that particular layer name will be highlighted. Just click enter. And the quantity will be calculated automatically. Save and close. And when you refresh, you'll get the remaining quantities. Okay. Now you can see here the compound wall quantity was not taken. So it's 0. The rest has come in. I'll save the same and go for the next story. And when you proceed to the next story, make sure you change the story name over here to ground floor and refresh. Now the entire quantity has disappeared. It doesn't mean that the quantity has been deleted. It's been stored in the earlier one. We go back to foundation and refresh the page. You can see the work names and the quantity over here. And when we switch it to the next story, you can see that the quantities and the work names are having changed accordingly. Now, you don't have to repeat giving the parameters. You just have to go to, you'll have to proceed with the scanning part again. Now, for this particular story, I have floor slab, I have an architecture plan, I have bricks to be calculated, brick volume to be calculated, and structure quantity to be taken. So I'll start with the slab part. And here, if you have a uniform slab projection, you can give that value here and click select for the outline. If you don't have a uniform projection, you can let this empty. I'm taking a 10 centimeter projection over here. Slab depth is 12.5. Sloped area, I'm not using a sloped slab. Now for the deduction. Deduction refers to a cutting or an opening in the slab. Here, I'm first going to take the total quantity and reduce the openings from it. So this one is to be kept no initially. And when you're dealing with the slab area, you will also have to take the outer brick area also. So this should be yes. And if I'm giving a throughout sunshade, you can keep this value yes. Or if you're giving it intermittent, keep it as no. Pick slab option, come to AutoCAD. I've already drafted a polyline to represent my slab. You can use it. Select. And if you inspect closely, you can see another line formed here. This one represents my slab projection. And as I mentioned earlier, since I'm already drafting a polyline, if there is unequal projections, I can use a polyline to indicate the unequal projections, like the one drawn here. Save the data. You may ignore that error. That's a error with my software, not the entire thing. Now I have to cut down the openings. For this, I'll change reduction area to yes. I won't be reducing the brick wall thickness, so it's no. Pick slab, come back to AutoCAD. Then you have to select the portion you are taking as reduction. You can't provide a slab in a staircase because you will have to travel from one floor height to another. So this is the opening. Similarly, all ducts are openings. You can pick the same. Slab and now I'll just go with sunshades. In order to scan sunshades, close all these ones as no and set this one as yes. Pick slab, come back to AutoCAD, and here I won't be giving a sunshade. I'm giving sunshades. Okay, I'll just give one to represent. Okay, now the sunshade is automatically drawn and the quantity has been already taken. You can pick sunshade similarly. Now continue this procedure to get the sunshade quantities. Then come back, save, close, refresh. Then come to the scan arc path. Over here, you will have to go to setting some properties. Similar like the beam ones, you will have to give the layer names here also. Walls are given in wall layer, compound wall and compound wall layer, and any other wall names you can also add that same. If you're naming the layers based on thickness, you can also add the same. Okay, similar like before, you just have to give the column name and the default width of wall. Close, can, come in, scan the architecture drawing completely, enter. You can see here also send lines being created by the software itself. Just wait until it's complete. You'll get a dialog box. And you can see that quantity for wall, including the walls over windows have been calculated. Door, window quantities have been taken. Even ventilator quantity has been taken. You can go for the corrections over here. Okay. Now, after doing the corrections, you can see, come back to the drawing and check if the corrections are done properly. In case the corrections are not done properly, that means that there is a drafting error or a conflict encountered by the software, which needs our human correction. Okay, this is a minute correction you can do as per your requirement. Now the corrections are done. My quantity is completely entered. You can just name the center lines. Okay, now you can inspect all center lines. Now I have mentioned earlier that you will have to reduce the lintel height from this particular table while scanning the joineries. So lintel height you will be changing over here. Now earlier we calculated the total depth minus beam depth minus lintel depth, that is 15 to 55. Correct that over here so that the lintel brick height is corrected above the joinery area. So the wall depth will be calculated in this particular region. That is the brick quantity will be calculated based on this particular height. Okay. Now save And you can see the quantity is being updated over here. Save and close. And you get the quantity for almost all the items over here. You just did a scan for 2 minutes and you got data for almost half the quantity in this list. Now you can go for the scan structure, just the same procedure as before. We'll have to change the font thickness. I'll just speed up a bit because we are running out of time. And select this portion, enter. For the next session, you will be learning how to do a drafting properly. Now here, this has not been scanned because it's in polyline. We just split the same and just go for scan. Come here, select enter, and it will be calculated automatically. So you can do corrections even after doing the scan also. Go for the corrections, one after the other. Rejoin and correct junctions. Okay, now that's about the structure scan. Save and close. Now, as I said earlier, I'll be doing the quantity calculation for staircase over here. 90, 15, 30. These were measured from my drawing earlier, so I know them beforehand. You may take it from your drawing and fill in. I'm taking the slab depth. That is the base slab depth as 12.5. Floor landing, I'm taking it as 0 because here in my drawing, I've already added the floor landing area in my slab area. I don't have to do the double calculation, so I'll be avoiding it over here and giving a value equivalent to 0. Mid landing length will be equal to the landing gap over here, which is almost 90 centimeter. And height of stair will be calculated automatically. I have to do a bit correction over here to get the. Okay, now that was the correct height. Calculate volume, and the volume will be calculated automatic. This is like a calculator. You have to give the input values, calculate, and the value will be here. Save that and close. You can get the calculations by saving it to Excel. It won't be added to the report directly. Close, refresh, and come to the CAD utilities part. You have a set of CAD utilities to be scanned over here, which I will not be repeating for the time being. Just save that, and you can see the staircase quantity over here. Save and close, refresh. Now there are missing quantities because I haven't gone for the CAD utility scan. And when we come to the report part, and skipping the scan for headroom, which might take another 5 minutes. Okay, now coming to the, now save your file. When you save your file, you can do the step initially also. I just missed on the same. You have to save your file while selecting the template itself, so that you don't break the link between the AutoCAD file and the Estimax file. Save the file in the same folder location where you have saved the AutoCAD file. Now I have done it in the desktop. Then select the folder, save, and go for the reports. You have different reports over here. You will get the story-wise report, work-wise report, abstract-wise report, tender report. Even the rate analysis report can also be taken. We have summary reports. We can look into these detailed reports in detail in the next sessions. I'll just show a sample when you export. I have already done this estimation earlier, so I'll show the final report of the same. This is a work-wise report. You have the quantities sorted in terms of work. So here you can see the work foundation and all items scanned and quantities taken. And for total rate, it is 27 lakhs for this particular building. This particular building costs nearly 27 lakhs for civil construction, including electrification and plumbing cost. A person has been taken for the same. Okay, as you have noted, I started the session at 8:15. I have completed the session at 9:10. I took nearly 1 hour for teaching how to do estimation in Estimax. So if I've actually done this project rather than talking to you, I would have completed in 30 minutes. So you can see how fast you can work with Estimax and generate a report as good as this one without making much errors or without making even a single error. If you're good with it, you have all the calculations in the detail sheet over here. You have an abstract report over here. You have all the calculation backup in a detail sheet also. And if you want a rate analysis report, you can get the same even from uh, over here. You can go for a summary report. It will be saved in the same folder. Once you give the folder location, it will be used for all other files saved. You can see I have taken a summary report wherein entire details, the area of the plot, uh, the material used, the items coming under each work, the cost per item, and the total cost is represented. You have an item short report, a material detail report, a material short report, all this coming up in just a click. And the total time you actually require is just 30 minutes or 45 minutes if you're good at it. Think the speed you can achieve just by using a software. I'm not saying that you should use Estimax itself. There are plenty of softwares available and coming up in every year. You can rely on our software to get a better, fast, and error-free report. Or the only thing is that you have to learn the basics so that you can check the equations within the software and make sure that the proper calculation is done. Only thing required is that you should have the basic knowledge and how to use the software. With that, you can create a report as easy as this, even without worrying about the rate analysis part. Okay, I hope we'll see each of you for the next session also. And next session, we'll have the part where we'll be discussing about how to draft the file in AutoCAD. I've started directly from a drafted file. Next class, we'll be learning how to draft this particular file in AutoCAD. You might be knowing, so we'll just discuss about the CAD utilities and other items you have to take into account while doing the estimation part. Okay, with that, I'll be winding up the session for the day. Thank you all. If you have any doubts or queries, you may ask the same. I hope you'll clear your doubts in your next session. Thank you all. Good night.